Today, I'm going to teach you something hard to understand. It's something I've had to work very hard to understand myself, but I'm finally ready to share it with you. But more importantly, I want to show you how this concept can completely change how you live and think. Some of you may have heard of Bayes' theorem. Most of you probably haven't. It's a mathematical formula that helps determine the probability of something given our previous credences. Credences are simply just the chance we assign to something being true. One could say, how on earth could an equation change the way you think about life? And yet, here I am. Once I understood just how far-reaching this theorem was, I decided to look into it more. The first few passes at it, I was left more confused than I was before, so I went on a quest to truly understand this concept. I found the answer in a book called The Big Picture by Sean Carroll, a physicist and cosmologist. This is now my favorite book. He devotes all of Chapter 9 and Chapter 10 to Bayes' theorem. And finally, I have internalized the implications and fully understand the concept. It works like this. You have a theory or belief that you think could be true, but you want to know how likely is it for the data to support your theory and how much that data and evidence should affect your original credence for that theory being true. For example, let's say that your manager finds a cracked pipe hidden in the storage area and is determined to find the culprit. There are 200 employees that work there. He decides that every single one of them has to take the drug test right away to find this crackhead. The test that he forces all the employees to take is 99% accurate. The test results come back, and your manager finds that the tests have identified 3 positive results. What is the chance that one of the 3 randomly selected is an actual user? The intuitive answer would likely be 99%, because that's how accurate the test is. Things aren't looking good for these 3 people. But Bayes' theorem tells us differently. So here is the actual Bayes' theory in all its confusing glory. This looked like gobbledygook to me when I first saw it. So let's walk through the process and then talk about the implications. First, we have to convert these letters into percent numbers that represent the likelihood of these events. Then we can replace those percentages with the actual numbers of your workplace. Then we can calculate those back into the probability of the likelihood of one of the 3 people that tested positive being an actual user. So what do we know about the likelihood of someone being a crackhead at your work? Well, we know at least one person most likely is because we found one cracked pipe at work. Or at least, that's our best guess. This is the most subjective part of the Bayesian process, yet it's critical to have a starting off point. As we collect data, we can update our prior credences along the way. The Bayesian process is meant to be used over and over. So if there's 200 people that work there and one is a crackhead, then the likelihood or credence of that being the case is half of 1%. So let's plug that into our theorem. Next, we need to plug in the likelihood of the test correctly testing positive for the actual user. That is the 99% chance of the test working correctly. Now, most people just stop here when trying to decide just how likely something is. We could pass down judgment on all 3 that tested positive because in just 1% of cases would we be wrong. But we forgot a critical step. What about all the non-crackheads that were incorrectly tested positive? If the test is only right 99% of the time, that means a few could get caught in the crosshairs. So we need to do the math for them too, and this will start to become more clear. We can't just take 1% out of the 100% of people unjustly tested positive to get that number. Why? Because we are fairly certain that the test would also catch the real crackhead. So we need to take him out of the equation. So we take 100% and subtract the 0.5% from our original likelihood and are left with 99.5%. Then we can multiply that by the 1% inaccuracy of the test to get our number of false positives, here. Then we take the suspected likelihood of the real crackhead and divide it by all the people who tested positive. Turns out that there was 2 people that are incorrectly tested positive and 1 person that is the real crack rock smoker. So what is the chance that one of them is actually the druggie? About 33%, or 1 of 3. We could run the number again after a second drug test and see that the 1 person who is tested positive now has a huge jump in likelihood of being the real crackhead. This seems logical when you think about it, but it has much deeper implications than just crackhead hunting. Bayes' theorem is used for looking for downed planes in the ocean, filtering your email for spam, calculating the likelihood of cosmological models that explain the origins of the universe, and how likely our belief is in the supernatural. Like I said, we need to use it over and over to make our theories more accurate and closer to the truth. We keep updating it with new information and evidence and factor it in to the overall chance of something being true or not. There are several life lessons we can learn from this. Number one, you can't pick and choose your evidence. You have to take it all. Not all of the evidence needs to be given the same credences, but it is important nonetheless. I'll give you an example. Say your friend comes to you and shows you 2 photos of the Loch Ness Monster. Acting like he's just painted you into a corner, he says that you would be closed-minded not to believe that the Loch Ness Monster is real in light of these 2 new photos. Now, the mistake your friend is making is that he's ignoring all the other evidence that says the Loch Ness Monster isn't real. For instance, the original photo that started the rumor was confirmed to be a fake. Also, the fact that we've looked multiple times and found nothing in the lake. Nothing living or bones of the dead. The lake is too cold for a reptile to live in it. It could be a warm-blooded animal like a seal, but we haven't seen anything that big from any fossil records in the past. So 2 grainy photos is still some evidence, but when calculated up against all the other seemingly overwhelming data, it is unlikely to change your mind on whether you believe in old Nessie. The new information is still worth considering, but our prior credence should be in the realm of how likely it is that someone falsified evidence that there is a great monster in a specific lake, than the likelihood that there ended up being a real monster in that same lake. It's not a 0 chance, but extremely unlikely. Also, the fact that people want it to be true needs to lower the credence for that theory. So even though you're being meticulously open-minded to new information and evidence, you might be judged as closed-minded when other people make this mistake of ignoring or being ignorant of the data. This leads me to point 2. It's extremely important that you never set your prior credences all the way to 100% or 0%. If it is, then no amount of data or evidence could ever persuade you. This is irrational and dangerous. Remember, religion and some philosophies try to assign value to believing something without any reason or evidence to do so. People that say, you just gotta have faith, are trying to convince you that you should move some beliefs to 100% or 0%. This is problematic for many reasons. Firstly, what are the chances that people believe everything correctly the first time you think about it? Almost 0? And even if there was a person that perfectly guessed the correct way to think about our whole universe and everything in it, we know right away that we don't all possess that information or belief. Secondly, if we can never have our minds changed, then we are never going to be peaceful with other people. Some people believe that if we don't believe in their beliefs, then we deserve to die. Or they try to force their faith into schools or the government. If faith is believing something without reason or evidence, then it can't be accepted. We all have to find the truth on our own. Being fed flimsy faith-based beliefs will only stand in the way of testing these things for ourselves. If you set some beliefs at 100 or 0%, then you're only hurting yourself and denying evidence that points you closer to the truth. The truth that reality provides, and one that we could all agree on. It's not an easy thing to do because we have beliefs that aren't the same as other people but still manage to explain the same evidence. Those won't move your belief much at all when you use Bayes' theorem. However, there are times when information is strongly against your belief. Say if you thought the Earth was 6,000 years old, but all the scientists are telling you in 12 different ways that we know it's much older than that. You could try to explain it away and say that God created the universe that looked like it was much older than it really was. But that is a more complicated theory, and complicated theories tend to be true less often. So at the very least, that should lower your prior chance of it being true. Think of it this way. Let's say we have 3 theories that explain the planet's movement in our solar system. The first theory says that it's all about gravity and it follows the rules of Newtonian physics. It gets us to the moon and back and works nicely. Then there's a second theory that believes there's an angel assigned to all the planetary objects driving them around. Both are simple theories, but what if there was a third theory that suggested Newtonian physics is responsible for the objects in our solar system moving around, except for the moon? Only the moon is driven by an angel, and it's just a coincidence that they drive it in the same way that the Newtonian physics would predict. This third theory is more complicated. It holds all the theories of the first one and the theories of the second one, but makes arbitrary distinctions between them. And that should count against its credence for being true when explaining solar system objects moving in our solar system. Some theories are getting harder and harder to prop up. What if a theory made a prediction that people are going to stop believing in that theory one day? Then it would make sense that as people stop believing, it would count in the theory's favor as evidence. But wait, doesn't that mean we have to count a lot of people believing in it as evidence against it? Self-proclaimed Christians make up the biggest group of theists at 31% of the world. That should count against John's prediction made in the book of Revelation of people not wanting to believe in God in the end times. We could always say, well, it's not the end times yet. But preachers use this prediction to add credence to bad things happening that could be interpreted as the end times. You can't have your cake and eat it too. Good theories are able to make specific predictions that are testable, and then we can use Bayes' theorem to update our belief in that theory as we gather evidence. Religion makes very few useful predictions, and they're usually not very well defined. What if we all use Bayes' theorem to help update and change our beliefs as we live our lives? What if we could all agree that we base these beliefs on reality and evidence? What would happen? Regardless of where we all start in our credences for any one belief, we would all eventually end up believing the same thing if we all knew everything that everyone else does. This is why so many scientists end up believing the same thing. Most of them read the same papers that they put out that hold up new evidence and data. There are disagreements interpreting the data, but given enough time and evidence, they come to the same credences for things that we believe in. In fact, someone won a Nobel Prize for proving this mathematically using the Bayes' theorem. How likely is this to happen? Not very, but at least it gives us some hope. One day, I believe that people will understand and use Bayes' theorem on the regular, and it will just be a way that humans process and update our knowledge and beliefs. We can't get there if most of us are holding on to beliefs and are assigning them 100 or 0% credences. This is the first step. I used to believe in God, and it wasn't until I loosened the grip on my belief system that I could even consider evidence and start to let that change and affect how I think about the world and reality around me. Little by little, I started to see and test the evidence for myself. If I couldn't understand what the scientists were saying, I had to do research so that I felt confident in their assessment of the data. If I don't do some research myself, then I shouldn't be very confident in my credences. If we could just relinquish some of the stranglehold on our beliefs and let them be tested with data, that's the way that we could all start to agree with each other and be a better people. Thanks for watching, and I'll see you next time.